Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 1792, maximum average pass ratio. This question has recently been asked in Amazon, and in this question we will be utilizing concept of greedy and heap data structure. Now let's have a look on the problem statement. Here they have said that there is a school that has classes of students and each class will be having some final exam. They are given 2D integer array classes. Like this is the 2D integer array classes where ith item is having pass I and total I. What is pass I and total I? That in the final exam from the ith class we have total I number of total students. From those students, pass I number of the students will pass the exam. We already know in advance. So these three are the classes in my school, and every class will have first item as the total number of students who will pass the exam, and second item is total number of students in that class. And apart from that, we are also given extra students. And what are these extra students? These are the brilliant students that if I assign any of these students to any class, these students will definitely pass the exam. It means that let's say if I pick one from the extra students, and if I add that student in a second class or first index class, it means the number of passing students will also increase by 1 and number of total students will also increase by 1 because they will definitely pass because they are brilliant. And what is pass ratio? They are also saying that pass ratio of a class is something total number of passed students divided by total number of students. So this is called pass ratio, and this we have to return. Return the maximum possible average pass ratio by assigning extra students in your classes. So to summarize, we are given a 2D grid where every row is having a number of passed students and total number of students in that particular class. In the class 0, I have one student who will pass the exam. 2 is the total number of students. Same for in class 1 and class 2. Okay. These are the extra number of students that we can utilize to increase our passing ratio. What is passing ratio? Students who pass the exam and total number of students in that particular class. So let's say for class 1, my passing ratio is 1 divided by 2, which is 0.5. This is the passing ratio. For class with index 2, it's 1, that all the students are passing. And what we have to return is maximum average passing ratio. It means sum of all the passing ratio from every class divided by the total number of classes. All the passing ratio divided by total number of classes. This we have to maximize. That is passing ratio of all the classes we have to maximize. The number of classes is a constant. This is a constant. Even if we discard it, so let's say sum of all the passing ratio we have to maximize. That's our aim. And what is the effect of these extra students? Because let's say my first class initial passing ratio was 1.2, that is 0.5, and after adding one brilliant student to that class, the passing ratio will become 1 plus 1 divided by 2 plus 1, which is 2 divided by 3, that is equal to 0.6 something, 66 something. So initially passing ratio was 0.5, then it was increased to 0.6. It means when I add a brilliant student to a particular class, the passing ratio will increase. And the maximum value of a passing ratio can be in any class is 1. Okay, so this is the thing that we have to do. We are given classes, passing students, total number of students, and the extra brilliant student. If I add extra brilliant student to any particular class, my passing ratio will be increased by some value. And my aim is that I have to maximize that passing ratio sum. Even if you ignore the average and make it equal to sum, that is also fine because total number of classes are always same, right? So now we will have a look on the approach. Firstly, brute force approach. So in our brute force, we are taking the same example. We are given classes, and this is the 2D grid, and this is the extra variable, number of brilliant students, and we have to assign these extra brilliant students to these classes such that the sum of passing ratio is maximized, or you can say average passing ratio is maximized. Both are the same thing. First of all, let's have a look what is the current passing ratio of every class. In first class, the passing ratio is 0.5. In second class, the passing ratio is 0.6. In third class, it is 1. It's already 1. It means 100% of students will pass. Even if I add one more brilliant student in that class, the passing ratio will not go beyond this. So these are the initial passing ratio of every class. If I take the sum of these passing ratio, it will be 1. Or you can say average is 1 by 3. Now I have the initial passing ratio, initial sum of passing ratio, and this is the time to utilize our brilliant students. And these brilliant students I have to assign in the particular classes. First of all, let's see. If I pick one brilliant students and I assign to every classes one by one, I will see what is the impact. Let's say if I assign the brilliant student to the first class, what is the change in the passing ratio? If I assign it to the first class, the total number of students who will pass the exam will be incremented by 1, and total students will also be incremented by 1. So it will become 2 divided by 3, which is equal to 0.667. And let's say I do not assign it to the first class and assign it instead on the second class, which is first index class. 3 divided by 5 was initially the passing ratio, and now after adding one more brilliant student, it will become 4 divided by 6. The same thing, equal to 2 by 3, 0.667. And for third class, it will remain 1, 3 by 3, which is 1. Okay. So now it is a time to analyze that which class is giving me the maximum change in the passing ratio. If I pick one brilliant student and add it to the corresponding classes 1, 2, 3, if I assign it to the first class, the change is this much, from 0.5 to 0.667. From 0.5 to 0.667. And in the second class, it is from 0.6 to 0.667. In the third one, there is no change. No change. Change is something like 0.01 something. Change is from 0.1 something. So this is the biggest change. It means I will assign the extra students in the first class. Okay. So how we can assign this extra students? Keep assigning the students to a class where we are getting maximum hike in the passing ratio. Now you may say, why don't we just directly assign both the extra students to the first class, class 1, 2? No, we cannot do so, because in every step when we are including one brilliant students, both the values are getting changed now. Both passing students and total number of students are getting changed. So we cannot directly commit it. Initially it was 1 by 2, then it became 2 by 3. After that it will become 3 by 4. Both the values are getting changed. So we have to check it. Instead we directly blindly say that it will be my answer. So what I'm saying is that every step you need to see what is that ith class who is giving me the maximum delta in passing ratio if I add one brilliant student to that class. So this was the approach behind our brute force, that I have two extra students. Extra student number 1, extra student number 2. When I pick extra student number 1, I will add it to the class. That class is giving me the maximum passing ratio change. So this I will add. And this, the passing ratio will become 0.667 after adding one brilliant students. This is the state, 0.667, 0.6 and 1. So this will be the state after adding one brilliant students. And now in which class I have to add one more students. This I will not add. I have to check from this and this. This is 2 by 3, this is 3 by 5. If I add in the first class, the second student, if I add in the first class, it will become 3 by 4, which is equal to 0.75. And if I add in the second class, it will become 4 by 6, which is 2 by 3, that we already know. So if I assign one more student in these classes, my classes have reached this state. This one, and this one. The first class will go 0.75 after addition of one more brilliant student. The second will go this, third will go this. So third is giving no change in the PR. And second one is giving same, 0.01 in the PR. And this one is giving 0.1 something, from 0.667 to 0.75. So the first class is giving me the maximum change. So in the second iteration also, I will assign my brilliant student to the I equal to 0 class. Okay, got it? So in short, what I am doing is that I am picking extra students, brilliant students one by one, and I will be iterating over the total number of classes, and I will pick the ith class which is giving me the maximum hike in passing ratio. And that class will be the one where I will add this student. And then I will move to the next student. Next student is 2. And this student also I will iterate over this number of classes, and I will see which class is giving the maximum increment in passing ratio. Let's say that is J. That can be I, but that is not sure. Let's say that is J. So in the Jth class, I will increment the values. And after incrementing the value, I can update the total passing ratio as well. In the total passing ratio, I am also, in my first step, I am also changing the value of the ith class. In the second step, I am also changing the value of the jth class. So change in the total passing ratio can be done in O1 time. So what I have done is, for every extra student, extra brilliant student, I am iterating all the classes. Let's say total number of classes are n, and total number of extra students are k. So the time complexity of our brute force will go n into k. And what is the space complexity? Let's say we are capturing this passing ratio in some array. Even if we are not passing it, we can do it in O1 time as well. But yeah, let's say we have taken extra array to store our passing ratio. In that case, we can call it order of n. This can be optimized, but it's totally up to you. So the time is the main concern, which is order of n into k in this brute force approach. K is for total number of brilliant students, and n is for iteration over the classes. As the constraints are saying that the extra students value can go till 10 to the power 5, total number of classes can also go 10 to the power 5. So it will be a very time taking operation, going n square around. So it's going quadratic. So how we can optimize it? Anyway, we have to take all the brilliant student and we have to add that student in some classes. And how we are picking the classes? We are just doing iteration over the number of classes. And if there is some way that I can pick the class in some optimized way, because every time I am picking the class who is going to give me the maximum change in the passing ratio. So this condition we can assign to a priority queue, and we can put all the classes into that. So in this way we can optimize it using priority queue, or you can say heap. So these are the 3 classes given to us, and this is the extra variable. Extra is the number of extra students, extra brilliant students that we can use in any class to improve its passing ratio and improve the maximum average passing ratio of the school. So as we already know that we will be picking the class which is going to give us the maximum increase in passing ratio if I add a brilliant student. Initially, the passing ratio was something like this, and then I have to utilize one brilliant student. That brilliant student, if I add in the first class, the passing ratio will be increased to this. If I add that in the second class, passing ratio will be increased to this. If I add that brilliant student in the third class, there is no change in the passing ratio. Now what is the delta? Delta is the increase or change in the passing ratio. So increase in the passing ratio is in order of 0.1 something, and it is 0.067 something, and this is 1, not 1, this is 0. There is no change in passing ratio. So what is the maximum change in passing ratio? That value is this one, this 0.1. It means if I add the brilliant student in the first class, that is going to give me the maximum passing ratio increase. So instead of iterating over this array again, I can use a priority queue, and on that priority queue I will maintain the priority on the basis of this value. So what I can do is I can keep the classes in the priority queue. No need to update the priority queue type. Priority queue is having classes, and the values will be sorted on the basis of this increase in passing ratio. Let's say increase in passing ratio is delta D1, D2 and D3. If D1 of any class is bigger than D2, that class should come before in the priority queue, right? So we can use a custom sort function for this. So we can utilize this logic for our priority queue. And we already know that in a priority queue, if I have to get the maximum element or topmost element from the priority queue, that is order of 1. If I have to add an item in the priority queue, that is log of n time. Let's have a detailed look on the time and space complexity in this approach, this optimized approach. What is the time complexity? To add any element in the priority queue, the time taken is log of n. And initially we are having n classes. I am going to add all the n classes in the priority queue initially, and I will keep on polling the best class, and then I will just add brilliant student in that class and I will put it back. So initially I added all the n classes in the priority queue. So for that, n into log n is the time. After that I did k operation. K is the number of brilliant students. For every brilliant student I am doing one operation. So this is going to be n plus k into log of n, that is equivalent to log of n log n, 2n. 2 is a constant, so I will just use n log n. And what about the space complexity? I am using order of n space because I am storing all the classes in my priority queue. So this is the time complexity. Initially we were having n square time, and now it is improved to n log n, which is better than the quadratic time. Now let's try to write code of this approach. We are having n classes dot length, and here I'm going to take a priority queue of classes. Class is my integer array. PQ is equal to new priority queue. In this priority queue I'm going to pass a custom function solution, let's call it compare, and now I need to implement the compare function. Private static integer compare. This compare function is taking class 1 and class 2. Here we will be comparing which class is going to give us the maximum increase in pass ratio. Passing ratio of first class, passing ratio of second class, double new passing ratio of first class, new passing ratio of second class. Okay, so what is this value? Class 1 number of students who are passing divided by class 1 total number of students, and this is giving integer. To make it a double, I'm just multiplying it with 1.0, and similarly C2 0 into 1.0 divided by C2 1. New PR is something instead of multiplication I will be adding 1.0. Similar to here, I'm adding 1.0 to C2 class 2, and I also need to add it on the total number of students plus 1.0, total number of students plus 1.0. Let's keep it in the bracket. So this is the new PR, new passing ratio. In the new passing ratio, I'm just adding one brilliant student to that class. Now we need to see the change. Double diff of first class, double diff of second class. First class diff is new passing ratio 1 minus passing ratio of 1. New PR2 minus PR2. And in the end, what we have to do is we have to compare these double values. Double dot compare. I want it in the decreasing order, so I will just keep D2 first. If later element is bigger, make it come to the first. Now my compare function is completed, and what I have to do now, first of all, I need to add all the classes in the priority queue. For I equal to 0, I less than n, I plus plus. Priority queue dot offer classes of I. I'm not going to add the exact class. I need to pass copy so that my exact array is not changed. Let's take a new class. Class is a defined keyword in Java, so I need to take another variable. Current, let's say call it current class, is equal to classes of I. What I have to offer is offer a new integer array where the first item is total number of students who will pass, current 0 and current 1. So this is my class I have added to the priority queue. And along with this, I also need to maintain a total PR, passing ratio. Total passing ratio is, let's say it is 0 in the starting, and we should take a double. Okay, so total passing ratio plus equal to passing ratio of current class. Passing ratio of current class. This function is not implemented. Let's implement this function as well. Private double pass ratio and integer array C for class. So what is pass ratio? C0, total number of students who are passing, into 1.0 to make it double, divided by C1. So this is the passing ratio of current class, and this is the total passing ratio. Now as I have all the classes in the passing ratio, for every brilliant student I will pick the best class and I'll do something. While the extra students are there, I will do something and decrement the extra students. What I have to do is I will pick the best class and add one student to that class. To pick the best class is this, which is on the top of the priority queue dot poll. This is the best class, and now I have to add one brilliant student in this best class. So best class 0 is the number of passing students in the best class, will be incremented by 1, and total number of students in the best class will be incremented by 1. You also need to update that value, that total PR. Total PR will also be updated. So from total passing ratio, decrement the passing ratio of current state, best class, pass ratio of best class, and then once the best class is updated, add the updated passing ratio. So it is going to be done in the order of one time. Pick the best class, decrement the current value from the passing ratio, and update the number of students in the current class, and then update the passing ratio as well. So keep doing this till you have any one brilliant student. So once this is done, you will be having total PR, total passing ratio. Total passing ratio is there, and what we have to return is maximize the average pass ratio, and this is maximized because we have picked these classes in that order. So if I have to take the average, I need to divide it with the number of classes, so this will become the average. That's all we have to do. This is my custom sort function, and added all the classes in the priority queue and extracted from the priority queue on the basis of our greedy approach, that whatever is giving me the maximum increase in the passing ratio. Let's test our sample test cases. It is giving me wrong output. Why it is giving me? Okay, because here I have pulled from the classes, but I have not offered the updated one. So to offer the updated one, what I have to do is priority queue dot offer new integer, or no need to make a new integer, just offer the best class. Let's test again. Now it is working fine. I'm submitting the problem. It is submitted successfully. I hope you have understood the approach. If you have any doubt, you can comment down below. Thank you guys. Bye bye.